And I'm going to talk about autonomous economy. The good news, actually, a few days ago, I checked in Google, and I realized that they actually adopted our definition of what's autonomous economy. So will be a little bit of a challenge how fast, actually, I can go through most of the content over here. Probably it will be the fastest way, so please pay attention. As of now, and this is the only propaganda slide that I will actually put over here, as of last year, we were sort of in the stealth mode. We finally, in public, so we're near Herzliya. We have the building over here, you actually can see it. And what we're actually doing over here, we hiring and we're partnering, and you can see actually the domain. Most of the efforts that we're focusing today is really around the trading, so we mostly align with the investment banking, less on the commercial side, and most of the people are actually not familiar with JP Morgan, but familiar with JP Morgan Chase, right? And this is one organization. 120 countries, so you can imagine that one in terms of scale, and clearly we don't lack of data. So if you really, one of the critical success factors for data scientists to have data, and we have a lot of data. When we talk about the trading, we talk about trillion transactions that we actually can go and analyze and so on. So those are the area. I just noticed in terms of data science, we're actually building two teams that will manage to under the same roof. One is the applied and one is the research. So it's really, we recognize the two elements. Okay, let's jump in and run into the topic. When we're talking about the future, and I'm going to talk about without trying to paint the future. Is it really a topic or it's not a topic? Is it RoboCop or is it Terminator? It depends which really book or movie actually you've seen. Or is it a Klaus Schwab that actually describes more in the topic model? I'm not going to describe the future in those terms in any shape or form. So what I'm going to do, I'm also not going to project when things actually happen. And the reason is because in general, we are lousy predictors. And if you take the IE organization, in the last 16 years, 30 times they had to revisit the projection around the cost of solar energy. So there is and those are the top scientists, really, that exist in those organizations every year. And the mistakes, if we can call it the mistakes, the errors in the projection are significant. We're talking about 5 to 6 times in terms of what it will be the cost of a solar energy. And you see it was predicted to be 22 years, it actually achieved it in 4 years. So I will not predict the future, I will not predict when it will happen. One thing we all recognize that things are actually moving fast, but somehow, strangely enough, we in this industry don't feel we're moving fast, right? And why the reason we feel? Because we are on a plane. When you fly the plane, you don't feel the speed of actually we're moving. But if you actually project and you actually see the level of adoption of some of this technology, it's a phenomenon. And here we are achieving to things like the last few years, look at Pokemon Go, how many millions of kids actually adopted this technology in 5-6 days, right? So we have a mechanism of actually to really to adopt a new technology, something that we haven't had. So the world is changing, and we are really looking at the storm. And the combination of the storm is really a combination of different laws. Some of them already we discussed over here. And I will just tap into the MECAF law. And the MECAF law is, we all actually, maybe not recognizing it, but the fact that we are in Facebook, Twitter, the connectivity element, the cost of the connectivity is really, you see how significant it is. And all of this exponential growth, we're still in exponential growth. So where is it heading? When I have to try to describe what is an autonomous economy, I'll try to find an analogy. And the best analogy that I can take a look at is the car industry. So we're looking at the mechanical cars, that's what we used to drive, our parents used to drive mechanical cars, that becomes more and more digitalized, right? So we have a problem today. What do we replace a chip, we replace a motherboard, we replace some computation. That's most of the likely the problem that we have. So we're moving from the smart car, which we're actually driving today, most of us, to basically an autonomous car that we're all hearing about that one. Actually, there is a change of phenomena between the smart car and the autonomous car. Up to the point from the mechanical to the smart car, it was all about driving experience, right? To provide a better driver experience to the driver itself, right, among the others. Now, in autonomous cars, we're not driving anymore. Somebody's driving for us. So it's about transportation. So the models are changing. And in the same thing, we actually can think about what's happening to economy. In the same mode, I'll talk about the agriculture, the industrial engineering, the information technology, which we actually today in a smart economy, and most of the things that we know is somehow digitized, right? So we talk about high-frequency trading and algo in a market and so on. So we're having more and more computation, and where does it take us? It takes us to a point that the humans are less of a driver. So if we have cars and smart cars, we're still in control. When it comes to autonomous, let's be honest, it's eventually we won't be at control. So what we're talking about, how we actually eventually shifting the control from the human to the robotics, right? And over time, yes, there is a transition period. And we are actually, so if I have to quickly define what is basically smart economy, it is an IT-enabled economy, but we are still the drivers. And when we're talking about autonomous economy, now we have a robot is actually in the driver's seat. What we are right now, we're actually in a transition between those two. This is really the point that it's really not clear who is driving sometimes, right? We will get to the point, is it the computer assisting us or we assisting computer? Who is assisting whom in this kind of a model? It actually reminds me of a joke that my father actually used to tell me about two elderly couple actually they're driving and suddenly they're passing a red light and the woman is actually screaming, Yankele, Yankele, you just passed a red light. The husband looked at her, what are you talking about? Am I driving? So the question is, who is driving over here? This is exactly the phenomena that we have over here. Who is really driving? And overall, eventually, it clearly will be very clear who is really driving over here. So where I'm heading to that one, Professor Shashua from Mobileye actually really describe very well what is the autonomous economy is all about and what's the framework. But all of those things are actually happening almost at the same time. So we're thinking about sensing, mapping, planning, and acting. The same thing, I would say, almost the same analogy. I can actually put that one side by side, what it does really mean. So with sensing, we're trying to figure out who's in a competition. In what context we're actually talking about. Is the macro context? When we talk about mapping, what's really the opportunity? What's the commanding indicators that we have here? So we really have to understand the environment by which we actually operate or we're trading, right? What we are. And we talk about planning. Is it the short term or is it the long term trading? What are we actually, where we are in that context? And we actually, when you act, are you bearish or you bullish, right? So those are the things that we really need to look for in a financial perspective. Now, if you take a look at what's the definition of autonomous, and I think pay attention to that one, it does interesting some of element that I'll talk about. I'll point you to assertiveness, right? And we'll talk about it in a second. Or self-termination, an ability to procreate, right? We're learning from nature a lot of the things that we can actually probably play and how we actually execute. What does it mean to be in autonomous state? So let's talk about that one. I just mentioned assertiveness. It's not fun. I won't be surprised if a car that is basically autonomous car that was trained in Norway will not be able to actually operate effectively in Tel Aviv, right? Look at that jump, right? They will wait for somebody to give you a permission to get in, right? So you have to have an assertiveness, and the same thing you have to assertiveness in your model. Sometimes you're bullish, sometimes you're bearish, and you basically to figure out how you actually operate in what market and what really makes sense. Things actually will change over the time. Where I'm heading with that one, we talk about economists, and this is actually based on a paper I forgot to mention. So if you Google it, you can see the paper that really talk about autonomous economy. That we talk about economists and how economists actually used to work as of today. Economists, because of the lack of data or the ability to process so much data, they'll put hypotheses, right? They'll put hypotheses, and interesting enough, in 1 year, we had 2 Nobel Prizes that actually won for 2 conflicting messages, right? One of them said, it's predictable market, the other says they're not predictable. How can two economists win a Nobel Prize at the same time on 2 conflicting messages? So when you ask him which one is right, they'll tell you it depends. It depends because it depends what you're looking at, in the context. So they're always right because, again, the depends is really the context that you actually apply. So where we actually have moving into ability now, and in the past we used to use agent-based modeling, now we're extending those agent-based modeling more with machine learning, more with reinforcement learning, and some other technology. So now we can actually have the ability to take with a lot of agents, right, a lot of data, and really bring it up into a model that we actually can make some decision. So if we take a look at the, for example, scenario, 2 cities actually side by side, they're competing on the same resources. They're competing on taxation, how many people will come to the city, they invest in university because they want actually more taxation, more students, change the culture, and so on and so on. I am really envisioning that it's very simple that you will have two cities actually with two analytical models competing at each other, and each one is actually trying to measure what's happening in the surrounding, in their context, and how actually they operate. Okay. Now, one of the things that I'm talking about in my paper is the entropy, and really talk about that. Really, what we're seeing over here, the energy of innovation is almost like an entropic force. And again, I will not even go into define it. It's really complex. But the bottom line, all of this technology is irreversible. Okay, so where we're heading is there's no way back. If we have to go back, we have to go to the real time and start to break it up. So all of the things that we have to basically to look forward versus backward. So what's holding us? If I said I cannot predict the future and I'm basically not going to paint how the future looks like, one thing we can do is try to analyze what are the things, the barrier they're holding us from reaching to that state. Okay, so if we analyze the barriers, if you're a country or if you're a large organization or even a startup, if you're trying to figure out, plan your direction, where are your future, right? What are the few elements that you can actually focus in order to get to autonomous economy? And we came actually with 4 elements. So it's a trust, supply chain, platform, and regulation. And I will dive in each one of them fairly quickly. Start with trust. Okay, there is no day that you open the newspaper or look at the TV or the news and you don't see one of those news. And we are familiar with those, right? So what we recognize, and I will say it bluntly, that in some cases people get into politics because of a lack of transparency in the system. If there's a lack of transparency, you can scam the system, right? So we are lacking a trust, and there's almost an epidemic. We're in an epidemic world that actually trust is getting lost and lost and lost and lost. So in order to solve some of those problems, I don't believe it's anymore to go to the human and ask them to basically to build more trust. The trust is basically is a currency for our economy, and we need that transparency so we can see what's happening behind that one. So how do we build trust? And this is a few of the ideas that I actually brought up. Clearly, we need the transparency. So we need to figure out how to provide the openness. We have to give back control to the end user. GDPR, among others, actually talk about it. So we need to give the individual control of their, and we basically shifting to a digital trust versus human trust. Some of the conversation was actually over here, should we trust AI? We don't trust almost ourselves. Now we're being actually asked to trust the technology, right? So we in a paradox over here fairly quickly. Talk about the supply chain. So it depends on which paper you write, McKinsey or not, and others will claim that around 75% of the supply chain is still manually conducted, right? So there's a huge opportunity because that's what really drives our market, how you are manage your supply chain. So let's take a scenario by which we want to ship some fresh food from China to basically to fresh food in California or any other place. Clearly, you can actually talk about smart contract today, and you probably can orchestrate that one. But the smart, everything after smart becomes autonomous. So the next thing of smart, things not always happen the way we expect, right? So in the supply chain, if this scenario, you can see a scenario where the trucks actually break down due to weather. And then immediately what happened, usually humans get involved. So this is where the contract is broken, and we actually need to figure out how we are addressing it. Here again, if it's autonomous contract, the autonomous contract, we said, okay, it probably will not reach as a fresh to California, but I can actually still achieve my goal if I sell it to the local market. So the same thing that what human basically logical we see, instead of trying to ship something that is already might not be a fit to the US market, can be bid into the local market and then basically shipped in the US. So there's changes that we need to do in the supply chain. What does that really mean? It means that we need to change our platform, for example. So we talked about some of the things you heard over here, the X and some others. Platform need to change. Our architecture need to change to be different. And now one of the things that I probably we will see over here that while let's take a contract today is actually modeled twice in the supplier and the consumer. Well, but there should be one contract. This will be one interpretation versus multi-interpretation. So we might see more kind of those interpretation in the middle, more like a relationship. So those are some of the things that we probably will see in terms of the changes, where we're heading and how we're decentralizing. I will bet actually that we're moving more and more to look like the human being. I'll cover that one in a second. When you're looking in terms of regulation, which is no better almost what industry we have the regulatory challenges. So when you see actually over the year how much US, every time we have a crisis, financial crisis, what the US government does, puts more regulation. More cost, you look at the cost of the government and the regulation actually grew up. What happened to the trust? The trust went in the inverse direction, right? So we have a basically different way, different opportunity today to actually, this is an interesting technology, to actually to leapfrog. And again, this is one of the regulation needs to try to figure out how to do that one. For example, if there's a bias, right? With technology provide a bias, we need to figure out how reduce the bias in that context. Okay, I'm sorry, there's the last slide. We actually, the 4 elements over here, think about the friction, how we reach to the water. We really need those innovation technology to go those. And the impact is really the fusion of all of those technology. I'm here. We have a booth over here. If some of those will want to talk to me, we'll be more than happy to do that. Thank you very much.
Thank you.
Thank you.